Many of you are probably familiar with leeches thanks to their infamous habit for bloodsucking. But that's only the tip of the iceberg as far as leech diversity is concerned. Leeches exhibit an astounding amount of diversity in terms of morphology, life history, feeding strategy, and ecology. They are found on every single continent with the exception of Antarctica, and there are only over 700 species. They're incredibly important as environmental indicators, as medical tools, and also as sources of medicinally important compounds, most notably anticoagulants. But despite their universal distribution and their importance for a lot of different fields, we don't know a great deal about leeches, particularly with respect to their evolutionary relationships. In fact, it was only in 2001 when it was confirmed that leeches are actually nested within earthworms. Oh, Jesus. Placobdella is a genus of proboscis-bearing or Rhacobdella leeches in the family Glossiphoniia. There are 22 known species at present, all of whom are found within North America, with the exception of one European species, which most likely migrated with its host. We know that they possess specialized organs which house endosymbiotic bacteria, and a couple of recent studies have focused on uncovering the history of that symbiotic relationship. Glossiphoniidae and Placobdella in particular have been really challenging for taxonomy and systematics, owing to really inadequate species descriptions, a preponderance of obsolete naming, and a seeming lack of informative morphological characters. The last phylogenetic analysis that was performed found many of the genera to be poly or paraphyletic, and several of those were sunk into Placobdella, so the genus is in need of a serious taxonomic revision. To address this problem, I collected species or specimens from across Ontario, as well as the collections at the American Museum of Natural History. I amplified 4 loci, ITS, ND1, CO1, and 12S, and you may notice that there is only one nuclear locus there, but we don't expect that to be a problem. Leeches are hermaphroditic, and they reciprocally fertilize during mating, so we should expect to see the same signal from both the mitochondrial and nuclear loci. My sequences were aligned and adjusted for quality using Genus, assembled and adjusted for quality. They were aligned using MAFT. I built my tree using RoxML and did model testing using Partition Finder. So the resulting tree recovers Placobdella as monophyletic. It recovers all species as monophyletic, and we have 2 unidentified specimens which are potential new species. One of the clades of particular interest is Placobdella rugosa. So in recent history, this species has been sunk, then resurrected and redescribed, owing to the incredible diversity of dorsal pigmentation patterns that you see. And in fact, if these 2 specimens were collected from exactly the same locality on the same day, to give you an idea of this diversity. Furthermore, the species Placobdella pavillifera, which has again a completely different dorsal pigmentation pattern, is nested within rugosa, suggesting that it may not be a legitimate species. The other thing that's kind of notable about rugosa is that we see short branch length here, despite the fact that we collected these specimens from as far-ranging as Northern Ontario and New England and Nebraska. In fact, what's really neat is we don't see a great deal of genetics or geographic signal across the tree at all. So given the fact that these species are relatively small, they're quite sessile, they don't survive long outside of water, they don't tend to stay long on their hosts, and they're never found in moving water, you would expect to see quite a lot of geographic signal. And while we do see the western clades grouping together, we don't see the same with a lot of other clades, especially the Mexican species. And what's kind of interesting even further is that the European species, Placobdella crostata, nests within the Mexican Placobdella vimonii. So there's clearly a lot of work to be done here. I'm currently working on incorporating the remaining taxa into my phylogeny. At current, my taxon sampling represents only about 2/3 of the genus, but I do have DNA for the remaining taxa and intend to situate those in the near future. I'm also generating a large data set for Placobdella rugosa to try and tease apart this kind of the way that populations are genetically isolated or connected across the landscape. And I intend to expand the scope of my research to generate a phylogeny encompassing all of leech diversity, which does not currently exist. So with that, I'd like to thank all of my collaborators, most notably my supervisor, Dr. Sebastian Fist, and I'd like to leave you with this charming picture of baby leech.
Thank you.